today's lesson, we're going to talk about sum and difference formula. So you have a sine formula, cosine formula, and tangent formula. When you have a sine, adding up two angles to get the angle you wanted, you're going to mix sine and cosine multiplications with rotation of the angle, but sine itself is going to be same. If it's addition, use addition, subtraction, subtractions. But when it's a cosine formula, you're not going to mix it. Cosine will be multiplied together with different angle, but when it's addition, it will become subtraction, subtraction become additions. Tangent formula is given. I'm not going to expect you to memorize it. You should be able to use formula sheet for this section. Okay, so let's look at the first problem and see how we're going to bring this problem using the sum and difference to find exact value. First, we need to remember again with 30 degree, 45 degree, and 60 degree measurement if you're not going to memorize the table, right? Then we know using these three angles, and we also have 90 degree, 180 degree, and 270 degree measurement, right? Using those angles, how do I bring 15 degree, right? That's going to be using cosine 60 degree minus 45 degree will be cosine 15 degree. This means we're going to use this formula right here. So that gives you cosine 60 degree times cosine 45 degree plus sine 60 degree times sine 45 degree. And we know cosine 60 degrees 1/2. Cosine 45 degree will be 1 over square root of 2. And when you rationalize it, it will be square root of 2 over 2. So when we write that down, we will have 1 over 2 times square root of 2 over 2. And sine 60 degree and sine 45 degree will be square root of 3 over 2 and 1 over square root of 2. When you rationalize that, it will be square root of 2 over 2. So you will get square root of 3 over 2 times square root of 2 over 2. When you multiply, you get square root of 2 over 4 plus square root of multiplication. You should be able to multiply different radicals, so it will be 6 over 4. Same denominator, so if we simplify it into one fractions, this is the value you're going to get for cosine 15. Let's try another one. What about 105 degree? Which of three angle can you use to add or subtract to make 105? Probably 45 and 60, right? So this is going to give you sine 60 plus 45, which will give you 105. That means you will get sine 60 times cosine 45 plus cosine 60 times sine 45. And when you find those value from those three triangle, you get sine 60 square root of 3 over 2, cosine 45, 1 over square root of 2, which rationalize to get square root of 2 over 2. Cosine 60 is 1/2. Sine 45, same thing. And when you multiply, you get square root of 6 over 4 plus square root of 2 over 4. Because the same denominator simplified into one fractions, you get square root of 6 plus square root of 2 over 4. You cannot add these two radical because you have a different square roots. Example C is going backward. So what about this one? Cosine 80, cosine 20. When you combine that, you get 60. And we know what 60-degree cosine value is. So that's what we're going to do. So when I combine this, so when we're looking at the formula, we're going this directions, right? So then, because you have cosine, cosine together and sine together, that's going to be cosine formula. And it will be additions, means same addition. So you're doing 80-degree plus 20-degree. Opposite, so we'll be subtracting, right? So let me erase that for a minute. It will be minus 20-degree. And this will give you cosine 60-degree. And we know cosine 60-degree is going to give you 1/2. This is another problems when cosine, cosine together, sine, sine together, that's the cosine. And cosine, sine will be flipped. So if this is positive, this is negative, this should be positive. So we're adding 5 pi over 12 with pi over 12. And when you add that, it gives you 6 pi over 12. When you simplify that, it gives you pi over 2. Pi over 2 is 90-degree. Cosine being x value, cosine pi over 2 is going to be 0. E, because you have sine and cosine rotated, you know this is going to be sine, function of sum and difference. And it means if you have addition, you are adding. That gives you sine 60-degree. And sine 60-degree is square root of 3 over 2. Again, sine and cosine rotate. It means it will be sine functions. Subtract means you are subtracting these two given angle. So you end up getting 6 pi over 12, which is sine pi over 2. Sine is your y value. Pi over 2 is 90 degrees, so that's same point, right? Same points here. So y value is going to be 1. What about the G problem? We have sine 7 pi over 12. That's the angle that we don't know. And it's single angle, so maybe we can use sum and difference formula. How do we get 7 pi over 12? If I add pi over 3 plus pi over 4, right? Let's try that on the side. In order to make it same denominator, that will be 4 pi over 12 plus 3 pi over 12, which is 7 pi over 12. That's how I know that's going to be the same thing, right? If I have sine formula with additions, I have to rotate. So I will do sine pi over 3 with cosine pi over 4 plus, same sign, right? Cosine pi over 3 with sine pi over 4. Sine pi over 3 is square root of 3 over 2. Cosine pi over 2 is 1 over square root of 2. When you rationalize it, it will be square root of 2 over 2. Cosine pi over 3 is 1/2. Sine pi over 2 is square root of 2 over 2 also. When you multiply, square root of 6 over 4 plus square root of 2 over 4, same denominator, and combine the numerator. That's the value you will get for sine 7 pi over 2. Okay, let's look at example 2. Example 2 says sine x gives you this value in a second quadrant. So being a second quadrant is important because that's going to decide the sines. And for angle y, you have sine value as 3 over 5 and it's located in a first quadrant. So first quadrant means sine, cosine, tangent. They're all going to be positive, right? And we wanted to find the exact value first. So since sine is given, they are asking you to find the cosine first. With the sine and cosine of the angle, you should be able to find sum and difference, right? That's the exercise we're doing. So first thing we wanted to do is finding all three measurements because we don't know what this angle is going to be. So let's draw the triangle with the right angle on my right corner. Your sine is 12 over 13, so it will be 12 here, 13 there. And we need to know what b is going to be. And your b, how do we find b? It will be 13 square minus 12 square. So that gives you 169 minus 144, which is square root of 25 will be 5, right? So once we have all three sides, then we know what cosine is going to be. And because it's second quadrant, your second quadrant cosine is going to be negative. So second quadrant, you have negative and positive, right? So your cosine is going to be negative. And your cosine is like that, so it'll be cosine x should be 5 over 13 negative. Do the same thing for finding cosine y. So we have a sine, this is y angle, right? Sine is going to be 3 and 5. And your b is going to be square root of 5 square minus 3 square, which you end up getting 25 minus 9. That's square root of 16, so it should be 4. So your cosine should be 4 over 5. And this is first quadrant, so it will be cosine positive, sine positive. So that's the two cosine we have. With that, cosine and sine x and sine y, you should be able to find cosine x plus y. Cosine x plus y, you will get cosine x times cosine y minus sine x times sine y. So this value is negative 5 over 13. Cosine y, 4 over 5. This is 12 over 13, and this is 3 over 5. When you multiply, you get negative. You're going to, this is 13. You're going to cancel out the common before you multiply, so you don't have to deal with the large number. So you get 4 over 13. And minus, let's see any other comments. There is no comments. So when you multiply, 12 times 3, 36. 13 times 5, 65. You have to have same denominator in order to add, subtract. So when you multiply this by 5, you get minus 20 over 65 minus 36 over 65. So you get minus 56 over 65. What about sine? Sine, you're going to use the formula. So this is going to be sine x times cosine y minus cosine x times sine y. And we know that sine x is 12 over 13. Cosine y, 4 over 5. Cosine x, negative 5 over 13. Sine y, 3 over 5. When you multiply, you get 48 over 65. This one, you will get 2 negatives, so you're adding 3 over 13. In order to get same denominator, you're multiplying by 5 again. So that will be 48 plus 15 over 65. Okay, example number 3. It's a find exact value with your cosine x given and sine y given. This time you wanted to find cosine, sines, and tangents. We've been doing this too from example 3, but we didn't work with the tangent yet. So this example will show how to find cosine, sine, and tangent all together in one problem. So in order to do this, you need to make sure you wanted to find not only cosine value of x angle, but sine also. This is sine y, so you need to find cosine y also. So it means I'm going to graph here the angle x when cosine is 1/2. So then your a value is going to be square root of 2 squared minus 1 squared, which is 4 minus 1, so it'll be square root of 3. So that means your sine x is going to be square root of 3 over 2. And this is on your fourth quadrant. Fourth quadrant is positive and negative, so your sign should be negative. We do the same thing for y. So y, sine is 1/2. So if we wanted to find b is square root of 2 squared minus 1 squared, which is going to be 4 minus 1, so it will be square root of 3. So this is square root of 3. And your cosine y is going to be square root of 3 over 2. And it lies on the third quadrant. Third quadrant, you have both negative. So sine negative, cosine negative. So you have the angle you need. The value for x and value for y. Using that, we can find cosine, sine, and tangent. Let's start with cosine. So this gives you cosine x, cosine y minus sine x, sine y. And cosine x is 1/2. Cosine y is negative square root of 3 over 2. Sine x is negative square root of 3 over 2. Sine y is negative 1/2. When you multiply, you get negative square root of 3 over 4 How many negative? 1, 2, 3. So it will be negative square root of 3 over 4. This one you have same radical to subtract on same denominator, right? So this gives you negative 2 square root of 3 over 4 is what you get. And when you reduce common, you get negative square root of 3 over 2 for that value. What about sine? Sine, you should have sine x times cosine y plus cosine x times sine y. So that your value for sine x is negative square root of 3 over 2, negative square root of 3 over 2 for cosine y, plus cosine x is 1/2, sine y is negative 1/2. So this gives you negative 2 square root of 3 over 2 and plus, wait, you're multiplying, not adding. So hold on, let me erase that. So when you're multiplying, you get negative, negative, positive. That gives you 3. 2 times 2 is 4. And then you have 1 negative, so change it to subtractions. 1 times 1, 2 times 2. Same denominator, so when you subtract, it gives you 2 over 4. Reduce will be 1/2. Let's look at tangent this time, right? Go back to the formula, and we know tangent addition, sum of tangent. Formula is tangent x plus tangent y over 1 minus tangent x and tangent y. So we can find the tangent value also. Your tangent for x is square root of 3 over 1. Your tangent value for y is 1 over square root of 3, which is going to be, let's leave it as it is, because sometime when you do the multiplication, you can cancel out. So now this time we're using this 2 value. Replace it. So tangent x is square root of 3. We need to get the sine. So if it's a 4th quadrant, tangent is negative. If it's 3rd quadrant, tangent is positive. So this is going to be negative square root of 3 plus 1 over square root of 3 over 1 minus tangent x times tangent y. Because you didn't rationalize, this 2 will cancel out because this is square root of 3 over 1 times 1 over square root of 3, right? So this denominator, it's same as if you have 1 minus negative 1, which is 1 plus 1, 2. So your denominator will be 2. Let's look at the numerator. Numerator, you need to have same denominator. So when you look at square root of 3 over 1, have to have same denominator. So you multiply square root of 3 and square root of 3 on the numerator. It gives you negative 3 over square root of 3 plus 1 over square root of 3. And that gives you negative 2 over square root of 3. And when you rationalize that, it gives you negative 2 square root of 3 over 3. So if you rewrite this, the numerator, you actually get negative 2 square root of 3 over 3 over 2 is what you have. This means you're doing negative 2 square root of 3 over 3 divide by 2. When you change that to multiplications, so you can multiply 3 with 2 on denominator. Or let's reduce before you multiply so that you don't need to rationalize or simplify it. So that's what you get for the tangent x plus y. Example 4, we're going to try verifying using this formula, right? We did the verifying from previous sections before, but now knowing this formula, new formula, let's see if we should be able to verify this. So I will start using the fraction side, which is the left side. Then the numerator, I can use the formula cosine x minus y is equivalent to cosine x cosine y plus sine x sine y all over sine x times cosine y. When you separate this out into two fractions, because it looked like you wanted to make two terms, so let's separate out into two fractions. You can reduce or get rid of the commons. So here, first fractions, this 2 is common, so cancel it. And second fraction, this 2 is common. And you know cosine x over sine x is cotangent x. And sine y over cosine y is going to be tangent y. And that's how we get, or we can prove, that right side is equals to the left side. One more. What about if we solve that side? So use the tangent formula. Tangent x minus tangent pi over 4 over 1 plus tangent x tangent pi over 4. What do we know? We know that tangent pi over 4 is equals to 1. So when we replace that, we will say tangent x minus 1 over 1 plus tangent x. Which is going to be same as this. It's just the denominator switching the order, having a tangent first, right? And that's how we can verify it. Left side is equals to right side using addition, subtractions of the formula.